Astronauts to the moon.
Ignition sequence start. 3, 2, 1.
Houston, we have a problem.
Liftoff. We have a liftoff.
We copy you on the ground. You got a bunch of guys about to turn blue.
What you're seeing here is a mirage.
What's going on, everyone? It is Jaron from Jeranism, back with another live video for you this evening. As always, thank you for joining me. I appreciate it a lot, and a lot more than I can even say. Also, a quick shout out to those who make this channel possible. That is all my generous patrons. And to help support this channel, you too can join them at patreon.com/Jeranism. So I would greatly appreciate that, but let's get on with tonight's show. My guest tonight is somebody who basically lit a fire underneath the flat Earth versus globe Earth debate. We got him on camera here by showing his infrared observations, which have been simply incredible. Now, I can't do it as good as you can. I tried. And that is JT from the YouTube channel JTolan Media1. Of course, there's a link in the description to his channel, and you should subscribe right now. But let's go ahead and meet him. JT, how you doing, my friend?
Hey, great, Jaron. Thanks for having me on your show. I appreciate it.
Hey, I really appreciate you coming on. I do. Your observations have showed me quite a bit and showed the Flat Earth and Globe Earth community quite a bit as well. I guess the first question I want to ask, though, is how did you get into this whole line of observations or line of research, if you want to call it that? And then after that, I would love to see what equipment you've been using. But yeah, go ahead and tell us how you got into all this.
Yeah, so about 3 or 4 years ago, I clicked on my first Flat Earth video. Prior to that, I was watching, Mars anomalies, UFOs, moon, and other stuff for entertainment. And once I, clicked on the Flat Earth videos, I got, curious. And I said, okay, some of it seems ridiculous, and some of it seems, testable, like long-range observations. And I said, you know what? I'm going to go and show everybody how to properly measure the radius of the Earth, because I'm a smart engineer and I'm going to show everybody. And so I bought a camera and I went out to Santa Barbara. We go out there quite often with the kids. And my first observations were really puzzling. I was seeing too far. And that's how I got hooked. And I wanted to see farther. That was in February, and the weather was really nice. But most of the year, it's kind of hazy and foggy. And I started reading up on how I could see, beat some of the haze on the coast. And that's how I got into infrared photography.
All right, awesome. And you said that you are an engineer?
Yep.
Okay, great. And go ahead and show everybody, they might be interested in what exactly are you using to make these observations? What equipment have you been using? And do you have any plans to, change your equipment at all? Or, what's going on with the equipment?
Right. So I had an old camera, and I remember it had the, this is the camera right here, the Sony Handycam 120X. I don't know what model number, but anyway, I put a 2x multiplier and I have an infrared filter on here. And this was my first camera. I took that out, and I was just curious to see, if I can see through haze. And I spotted Mount San Jacinto, San Gorgonio, and it just amazed me. I said, oh my goodness, I can see through the blue haze. Now, you cannot see through thick fog or haze. I mean, that's probably a different technology. Mm-hmm. That's, military ITAR controlled, shortwave infrared. This is just near infrared. Most silicon sensors are probably sensitive up to, 900, maybe 1,000. The Sony sensor seemed to be a little bit more special. But anyway, I used this camera until my son dropped it and the tape inside got stuck. So then I was kind of pissed. So one time when I was in Buffalo, I really wanted to film Toronto. I think it's Toronto, across the lake. And so I went out and I bought this camera, small camcorder, Handycam. And when I got back, I actually opened it up and modified it. I removed the infrared filter from in front of the sensor. And this is the camera that I used to film the 500-mile video.
Okay.
So, I quickly realized that, hey, I should bring infrared cameras when I go on my business trips,
Right.
to see if I can see farther out to the, edge of the earth. And I was amazed how it can pierce through that, haze, the blue haze.
Right. And I was going to ask you if you do a lot of traveling, because I've noticed that you have quite a few observations from the plane. I said, man, is this guy going up just to observe flat Earth? Or so you have business trips then that take you across the country?
On, different business trips. I cannot get into details.
That's all right. No.
But
business trips, and then you're
on,
taking your cameras up there, and then observing extremely long distances, certainly much further than we should be able to see, even from an airplane. I believe that you should only be able to see about 200 miles.
Right. I was, I think in one of my videos, I showed a photo taken through the dioptra inclinometer or theodolite app.
Mm-hmm.
I was trying to test whether the horizon comes up to eye level, and there's some things one has to be careful, because if the plane is banking, you're not in
level flight,
what is
right?
called inertial frame of reference, and it can throw you off. But if the plane is flying level, then it works much better. So anyway, I wanted to eventually I want to tie an inclinometer to this camera so I can zoom in and actually have more accurate. But that's how it started. I wanted to see farther and hopefully identify land features and calculate if I should be seeing them. So this camera was great HD quality, but as you saw in that video, it's grainy, and I didn't quite like that. It could probably be improved through some video processing. Anyway, the nice feature about this, it's got 60x. Now, the other issue here is there's no viewfinder, and my eyesight is deteriorating, and the plane's moving around, and I'm trying to look at the small screen. I'm trying to zoom in, and it was frustrating. So let me show you my other camera, my next camera.
Okay.
This gigantic thing. Now, this is a, let's see, what is it? What's the model? AX53 Handycam. Much bigger. It has an optical, it's got a balanced optical head in here. When I move it around, here, I'll show you. Oh, yeah, let me turn it on. Maybe my battery is dead. Oh, there you go. Can you see that optical head moving in there? I don't know if you can see it or not.
Oh,
anyway,
I can see it.
Yeah, so this is great for being on a plane. When the plane shakes, the image is a lot more stable. Now, this is a 4K camera, and the nice feature is that I don't have to open it up and modify it. I just press a button here, and it goes into night shot mode. Let's see, night shot mode. It goes into night shot mode, and then I just put the filter on the front when I film during daytime. And most of the videos were taken with this camera. Really great camera.
Wow. So the ones of the plane shots, which I'm actually showing behind your image here, people can see those, the infrared flight over Gulf of Mexico, that's filmed with that camera there?
Yep.
Wow. Amazing.
Yeah, this is the camera. It's a really great camera. Now, one unfortunate thing is I filmed too much in 4K, and I was putting it on my computer, and then I realized I maxed out my 1 terabyte hard drive. So when you film in 4K, you gotta be careful, right? If you move the camera a lot, the data rate is much higher. So something to watch out for. Now, this was great. It's still kind of grainy. It doesn't let you control the contrast. Puts that greenish tint, and it was very annoying. And then finally, I decided that's it. I'm gonna get a camera conversion. So this is my Alpha 6000 with, here, let me show you the sensor. I'm gonna take the lens off.
Sure.
Oops. Here, I took the lens off. And yeah, you can see the sensor. It's a little bit darker than the regular camera because it has a film on it. It was converted by LifePixel.
Okay.
They seem to be saying they're the best, so I ordered it from them.
Yeah, people that have the P900 camera, I think that they can get those taken care of by LifePixel. They declined to do a P1000, the Nikon P1000. I know they declined to do that, but I actually sent mine out to somebody named Isaac Szabo, who does infrared conversions. He's going to take a look at my P1000 and see what he can do. So I have high hopes for that. But if not, yeah, check out LifePixel if you want. Or if you want to learn how to do it yourself, you can go to the YouTube channel Flat Reality Earth Explorers. They've got a nice little tutorial. I think you've been on a video with them before, an interview with you, where they'll teach you how to do that yourself. So yeah, check out that channel too if you want, and I'll put a link in the description. So great. And then what do you got behind you there on your right?
Yeah, so this is a Celestron spotting scope. It's actually different than the one I used in my first 100-mile San Jacinto video.
Mm-hmm.
It's actually a 100. I actually returned that scope, and I got this one, and I've also ordered a telescope, a refractor telescope, APO, and I hope to take that out to one of the islands, one of the Channel Islands, so I can be farther away from San Jacinto.
Beautiful. Wow.
When the weather improves, because right now it's been raining cats and dogs out here.
Now, when you're standing at the position there, I can't think of where, the dune there. What's the place that you...
Oh, Point Dume,
yeah.
or Dume, yes.
When
Some people corrected me, they said it's Point Dume.
Okay, sorry. Yeah, I guess that.
I think it's Dume, came from some French guy.
There you go. When you stand there, can you see out to the islands out there? And is there any islands that you shouldn't see that you're seeing, or?
You can see Catalina
Mm-hmm.
on most clear days. If you look west, you can see Anacapa, Santa Rosa, or Santa Cruz. You can see the islands. And also there's another smaller island kind of towards the southwest. I believe it's San Nicolas, but I could be wrong. I saw that island as well. I took lots of pictures on New Year's Day this year. I just didn't show it in my video. I'm just obsessed with San Jacinto because it's the farthest out there.
Right, unbelievable observation. 123 miles, and I've seen articles pop up on Metabunk, trying to, as they always do. I mean, that's their job. They can't. They're not going to allow somebody to make a flat Earth observation or an observation showing that it appears that we live on a plane. They're not going to allow that without coming up with some nonsense, as they always do. Doesn't seem to me that they understand that there's a lot of land in between. It's 123 miles. And then when you pull up the actual stats on that distance shot, I think it's unbelievable that the horizon is only supposed to be 15 miles away. And yet you're showing things right on the shore there of the land right across. And then you've got another, 115 miles on top of that is going to Mount San Jacinto. So also something you've been doing recently, which I haven't had a chance to watch in its full glory because I need to get some 3D glasses. Can you tell people about the last 3 videos that you've done, which are 3D related?
Right. So while I was looking at my San Jacinto pictures, I actually walked around quite a bit from different angles. And I thought, you know what? What if I can assemble a 3D picture so I can gain some depth perception to really identify features, let's see, A, B, C, D, E, and F. I mean, obviously, those features that I labeled in my picture were the lowest.
Right.
And, some people disagree with me. That's okay. But I had a certain hunch of what I was seeing. So I said, I wish I could conclusively prove it. And so in that frame of mind, I was going to my pictures, and I said, wait a second, I kind of walked around. So I took the pictures, and I started trying to flip between them, in Photoshop, enable visibility on one and quickly flip it to see how it moves.
Right.
And then doing that, all of a sudden the light bulb went on, and it's like, hey, dummy, why don't you create a 3D picture from this thing, So then I started reading online how to do it. I started playing with colors, and I was just shocked, after I aligned the two, because they were taking them at different angles. Once I aligned them, it's like, whoa, the depths just came out. And now what looks like a bunch of buildings smashed together in a 2D picture, now all of a sudden we can tell there's depth. And wow, that just like blew me away. So now I'm on this 3D craze to convert everything to.
Oh man, yeah. You and I were just discussing it before we went on the air, and yeah, I have to go get some 3D glasses to watch that stuff because that's going to be amazing. Yeah.
Do you see my poster?
I can't see. What does it say?
That's my poster.
I do see it. Yeah, now I can see Mounts and Jacinto there.
I turned it into a poster.
Awesome.
I got it from Walmart, but man, the quality is poor. It's got the striations from the printhead across it.
Oh man.
My wife was saying to go through, some high-end,
something nicer, yeah.
Arts place or something.
So go ahead, if you want to turn on your screen share, go ahead and do that, and we can have you start showing some stuff. And we can talk about Mount San Jacinto. We can talk about your other observations, and ultimately, I'd love to know your, opinion of where we live at this point, because it certainly is interesting the things that you're showing. I've talked about before the Monterey Bay observation across 13 miles where they were able to see the reflection of a mirror at the water level, which is just simply impossible when it comes to the sphere Earth that we've been told. And so, yeah, some of your stuff is really obviously the San Jacinto observation. And in a few minutes, let me see if your screen is up here. Yeah, so you're on the screen now. You can minimize that if you want the Skype screen. And then, so show us this, what you're looking at here in 3D. And then, remember everybody, I think 3D glasses are super cheap.
Right.
You should be able to get those and check this out. And tell me what you're seeing in 3D that maybe you missed in regular.
Right. So now I've actually let me go show my other
sure.
channel here, just in case people are not familiar. These are the 3 videos with 3D content. I'm kind of improving the technique, and with this one right here, I realized that if I'm in motion and I delay the video relative to itself, I can extract 3D content. And but this was really, just the first cut. It's okay. It's very dark. Mm-hmm. But tonight I've been working on the Louisiana imagery in 4K, and I found out that when I have the 2 layers, can you see down here? Actually.
Yep, your editor. Mm-hmm.
Yeah, this is already processed. Yeah, I had to process everything once with the 2 tracks. I combined it into one, and now I brought it in again so I can add some music and adjustment. But anyway, looking in 3D, I tell you, we can tell it is absolutely flat. Seeing a 2D image may be deceiving. We may think that, we have to identify some land feature in the distance that we can, all agree on. And that's kind of hard to do because there's some haze. But now in 3D, my goodness, I'm telling you, Jaron, I'm looking at this thing, and just the perception I get is that it's flat as can be. It goes out to, way in the distance, and then it just gets cut off by haze or
right. I was going to say, I've seen a few globe earthers take your footage, and then they always ask this question: is what is this curve back here? Some of your airline footage shows a curve in the back, or at least that's what they call it. And I think that we've said it so many times that it gets kind of ridiculous at this point that the way eyes work, the way that lenses work, and the way that your eyesight is only the radius of a circle. And so if you're looking out a plane window, if you look straight, that's as far as you can see. Ranty and I talked about it, Ranty Flat Earth. Everybody's talking about it, is the fact that you can only see in a circle. So what people perceive as a curve is not a curve. And I guess I'll just allow you to talk a little bit about that. And, have you heard people saying the same thing about some of your footage?
Right. And yeah, I'm thinking that we should be seeing a little bit of a curve, because when I use my theodolite app, the horizon seems to hover around 1.92 degrees. And except close to the ground, it's really close. But then as we go up, it starts dropping. And as you saw in that one video with Mount San Jacinto on New Year's, when I put that theodolite app down, it's already at 2 degrees at like 200 feet elevation, and it seems to stay there even from the plane. When I look down, it's about 2 degrees. So that tells me that it's the same as light reflecting off of a pool versus refracting inside the pool. When you look down into a pool, into the water, right? Mm-hmm. Below a certain angle, grazing angle, all of a sudden, boom, you have total reflection. And I think it's the same thing here, except the angle is much lower. And light reflects, actually bends at the interface between different atmospheric layers. So that sets the minimum angle at which we can see. That's at least my theory. So because it's down at 2 degrees, we should see a slight curvature equivalent to that 2 degrees. Now, it could also be the window, and I don't know how I can eliminate that without sticking my camera out in the open.
Don't try that.
Yeah. So, I think it's refraction. It may be the window. It may be slight lens effects, although the camera I tested at the ground level, and straight lines come out straight. But certainly I don't think it's the true curvature of the Earth. So it's not as good of a test. The real test is how far we can see based on landmarks that we identify. Now, granted, some people have criticized me, seeing 1,000 miles, 1,500, across the Great Lakes. I have a little bit of doubt on the 1,200 or 1,500. I'm not entirely sure of that, And I think it came out in the video, right? But people like to, criticize that. But unless we have something conclusive, we can't really say. Now, once I got into this high-resolution camera, you've seen those pictures. I think it's getting a lot more conclusive that we can see very far. And when I saw across the Gulf of Mexico, 800, 900 miles,
right,
that just blew me away. I said, my goodness, man.
Which is so far
absolutely flat.
Which is so far beyond what we should see, from an airplane, like I said. And I actually might have this up, do I? The Earth curve calculator, when you put the eye height at feet, let me put in, actually I'm not showing anybody. Let me show them what I'm doing. So this is just the Earth curve calculator, but I'm just showing you that when you change it to eye height of 30,000 feet, or actually we'll even go 40,000, even though, most commercial jets aren't up that high. But then if you put, 300 miles here, you'll notice that there's a half mile of hidden distance already. So if we go down to 250, we can see even at 250 miles, there's still a certain amount of feet that should be hidden. So really, it's less than 250 miles that you should be seeing, and that's from 40,000 feet. And like you said, you're seeing across Baja. And what was that distance?
I think it was around 800, 900
right. That's just
mile.
It's not close. It's not like you're seeing 275 and somebody could say, oh, refraction, and that there's looming and things are bending up behind the curve, which I still think is ridiculous anyway. But we're talking about hundreds of miles beyond that. So certainly very interesting. Did you want to show people real quick your San Jacinto footage, just so you can, I think what you said earlier, we kind of skipped over it, but the way you talked about how the land features seem to kind of stack up, and it almost, the 2D image is much different than you are saying the 3D image would be. But do you want to show people that?
Sure. You want me to play this video right here? Can you see my screen now?
Yeah, great. I'll transfer that over here. Yeah, so that's the San Jacinto video there. One of the videos I thought was an incredible observation, mostly also or including the fact that the distance that we're seeing, where the horizon is supposed to be, how far away this mountain is, and then you have to take into account all the land and how far above sea level it is. So, I think you're looking over Palm Springs here, aren't you?
No, this is, hold on a second. Here
Sure.
we go. Okay, here we go.
Yeah, so that's kind of what he's talking about there. You can see that land looks like it's just all, it's a 2D image.
Right. Yeah, see, when I was mentioning compression, it looks like these distances are equal on the screen, but in actuality, there's a difference of like 600 feet for this one and 300. And then, refraction is non-linear. And so the steeper the angle, the more we can assume it's traveling in a straight line. So I built a scale based on this difference here. And this mountain, just assuming straight line propagation, no refraction, etc., should be about, I think, 17. So it's slightly below, So this is a scale just built based on this. Now, if we built a scale, let's say, based on this building right here, we get a different result. And what that tells me, and what is obvious, there's basically what I call two zones of distortion here. One is we're going over water to mainland, right? And humidity is higher, Then from there out to the mountain, it's propagation through much drier air. And so there's different propagation distortions,
Right.
So,
and then you're talking about the compression, right? I mean, that's one of the things I think is.
And there appears to be compression. There should be compression because refraction is nonlinear.
Mm-hmm.
And so what is obvious to me is we're seeing this mountain much higher than we should. It should be like around here, just barely visible over the front. Let me go forward here.
Yeah, no problem. And it's one of the there's two observations that I think are not fully understood yet, flat Earth-wise, and that's the compression and then also the magnification. I think that we're starting to understand some of the other stuff a lot better, but there is some magnification going on, and on top of that, there's a heavy compression because of the reduced viewing angle the lower we get.
Right. The official theory is that refraction bends down, therefore it brings objects up and we see them, right? And initially when I observed Mount San Jacinto way in the distance, 2 years ago, I wanted to save the globe, and I said, aha, I know it's refraction, But if you want to do your due diligence, you don't just drop this topic, I said, wait a second, can I prove that? Can I really prove that it's curving? So I started thinking, how can I prove this, And the theodolite app was one way to kind of look down at the horizon and see if there's a dip angle, But yeah, I'm thinking of a test where we can have a bunch of drones, man, just flying, every, 500 feet or, a mile or 2 miles out, just a string of drones. And they can all fly up, and an observer can radio to all the controllers to bring them up as they need so that they're all in a straight line. Then we can get a sense that they're along the propagation path. you know. And if we have accurate altimeters or radar altimeters on all those drones, then we can get height readings, you know. So we're sampling along the propagation path of light. And then I think that test would really be a really conclusive test of what's really going on, which way is refraction acting here. You know, without that, we can't really fully, conclusively, you know, really say. But personally, I think, like I said in my video, the Earth appears to be flat, and the atmosphere is making it appear that it's curved. Objects, boats on the water seem to disappear in the distance because of upward refraction, which really startled me. I said, wow, you know, my goodness, how deep does the rabbit hole go, you know?
Right, which is, yeah, of course, the, you know, opposite thing that, you know, we're taught. And then the other thing that I think is interesting, and I'm showing here now, the Mount San Jacinto observation. But when you talked about you can talk a little bit about the dip angle that you're talking about.
Yeah. So in this video.
Yeah, there you go. We can see that good.
Right. When I was in Florida, you know, I'm looking at, I put it at 0 degrees and it's up here. And then when I move it down, I realize, hey, it's minus 1.2 degrees. Mm-hmm. So that tells me light is coming up from below the horizon towards my eye. So it has curved, because when you're really standing on the beach, you know, you should really see, I think I have a calculation here. Yeah, I mean, the angle should be about 0.06 degrees. And as you saw there, it was, you know, what was it? Negative 1.2. Now, I've checked the calibration on my theodolite. Now, most people say, oh, you know, maybe its calibration is off. And it's not, you know, it's plus or minus, you know, 0.2, 0.3. You know, the worst I've seen it. And of course, it's kind of inconclusive. It was like 0.4. You know, I tested it on a floor, you know. But I'll just say, hey, you know, the measurement there could be, you know, plus or minus 0.04.
Well, it
degrees,
seems to be, you know, it seems to me that really, you know, and I know the horizon, you know, especially by definition, is the apparent position where the ground meets the sky. And again, I've talked about this many times, that I think without a doubt the horizon is an optical effect and not a physical one. So when we're talking about how low it drops, because I've seen, and I'm sure you've seen, JT, the videos of sunsets where you'll actually see where the sun begins to reflect off of the, you know, you almost get an upside down image of the sun as it sets, which tells me that the horizon line is actually higher and more in line with when you showed that theodolite showing, you know, the line above that horizon. So it is certainly interesting when you talk about how deep this goes, because it certainly appears that every observation that we make, they've taken it and just changed it. You know, in this case, yeah, that image there that you're showing, you know, is the horizon line up as high as that? You know, who knows? Because we can only see so far before the angle gets too tight to see.
Right.
You know?
Now, the other fascinating thing, I'm still working on a video. When we start making long-range observations, especially with the high-resolution camera, now we can begin to line up land features that we recognize. And I've done a study looking at mountain peaks over Nevada. Let me bring up this video.
Sure.
Where is it? My Eyes of Glory. I just love this video.
I like that one. It's pretty.
Constantly. I had a cold, so my voice went out, and I wanted to narrate, but then I said, forget it. I'm just going to put dramatic music out here, and it turned out really good. But when we start seeing really far away, I was looking at some peaks that I recognized, and
JT, do me one favor, hit the full screen button on the just so everybody can see it a little bit better. There we go.
Is that good? Okay.
Beautiful.
I I noticed that peaks are not quite lined up per the Mercator map, right? And I have a video planned where I was going through observations over Nevada, looking back towards what appears to be, what is it? It escaped.
Well, this is the kind of observation I'm talking about too, where people can see on the screen now that it certainly appears that the further that we can see, just eventually gets blocked out by the atmospheric haze. And
Right. But where I was going was horizontally, there certain peaks are not lined up, and beyond 200, 300 miles, there is a curve when we plot it on a Mercator map, and that really fascinated me because now we can check the maps, right? Gleason's map versus a Mercator. Now it's known that the Mercator projection is not accurate, and it as you go towards the pole, right, it's stretched.
Right.
But that's another study that I'm doing, and I realized that can invalidate refraction, whether it's up or down. Doesn't really matter, because now we're looking at peaks and they're not lining up, and so we can make a judgment on which map is more accurate. It's basically doing, land surveying at long distances, and we may learn something interesting from this. But yeah, that's another upcoming video that I have. But yeah, you're right. In the distance, there's fog and there's all sorts of.
Do that right there. Go ahead and show that.
Oh yeah, Mount Shasta. Yeah. Drawing a blank. I think that's Mount Shasta. Seems to be in the correct direction, but slightly curved. But yeah, it's incredible. I'm not sure if you noticed in this video, there's some mountains way in the distance, and I'm not even going to begin to try to
place those.
Convince people of what I'm seeing. I mean, look at that.
Yeah, it's unbelievable. And again, people fail to realize, because they'll tell you, if you point out that Mount Shasta there that you showed, they'll say, well, clearly that's only the tip of Mount Shasta. That the rest of it is behind the curve, because people can't accept, or I don't know, we weren't taught it in school, that really things get smaller in the distance, at least from a first person perspective. And so all those things off in the distance are huge mountains, but they get progressively smaller as they get further and further away, to the point where we can't see them anymore. But people like to take that and say, oh, well, you're just seeing the top of this mountain, or you're just seeing the top of Shasta, where you're saying, no, that how far is Shasta away in that other image?
600.
600 miles.
Yeah, isn't that crazy?
Yeah. So I mean, think of how small a mountain like Shasta would be over 600 miles. It would be tiny.
Right. It's crazy. I know one of these days when it clears up over the valley, I hope to interest my friend in taking me up again. We want to fly towards Vandenberg Air Force Base from Edwards, and I think I should be able to see Shasta from 10,000 feet, but I'm waiting for that clear day when I can do that.
What is your opinion of when the best time is for a clear day? Is it just as easy as walking outside and saying, okay, today's clear, today's not, or do you think it's when it's cold weather, or do you think it's right after a full moon? What have you noticed?
Well, yeah, during the winter time, obviously we have really clear days, but also throughout the year it's fairly clear. I don't know, there were times when I went to the coast and it was kind of hazy, but inland was nice and dry. So it's kind of a hit and miss, but generally here in California, we have a lot of sunshine,
Yeah, it's very hit and miss.
In this picture, I wanted to point de May right there.
Yeah, I was going to say, is that Point de May, and then the islands out beyond that, or which islands are out beyond you?
And then this is Anacapa, this is Santa Cruz, and that's Santa Rosa, and I forgot what that is. But my first observations when I started this whole craziness were from here. I think Santa Barbara is somewhere over here. Let's say this is Oxnard, you drive around. It could be over here. And from here, I was looking out to Santa Cruz, and I could see almost close to the water. That's like 27 miles or 30 miles. And I could see this island too. But then I looked this way, and I saw this mountain right here and these hills. Now right here there's a telemetry site for the Point Mugu Naval Air Station. I've been out there a few times on business, and I could see those domes clearly, you know, from there. And these are barely like, I don't know, 1,000 feet, and here it's like, I don't know, 50 feet away. So
what I've tried to tell people too before, and I don't think people grasp this, but if like you just showed from Santa Barbara there across to the islands, and you said that was about how far? 20 something miles?
From here to here, it's about 27,
right.
Almost 30 miles. Yeah, almost 30 miles.
Right. So if if somebody we could take a boat and start it at the islands, and it would start to go across, this flat horizon to our right and head over towards Santa Barbara. And that boat would be visible from this perspective where we're looking the entire time. But if you then stood at Santa Barbara and watched that boat go off towards the islands, within 3, 4, 5, 6 miles, the boat's going to quote unquote disappear over the curve. And then it wouldn't reappear for somebody on the islands until it was 6 or 7 miles away from them. So again, this disproves the fact that the boats are going over the curve, because from this perspective, you would see no boats going over any curve to anybody else. It's just going straight across the horizon there. And then you've got people from either place that would see the boat disappear from the bottom up. They would, of course, be told that that means that the Earth's curved. But I think that third person's perspective, watching the whole thing kind of transpire and take place, tells us that the boat is simply traveling across a flat plane, and that the people on either end are actually seeing an effect of a visual effect, not a physical effect of that boat going over the curve. Does that make sense what I'm saying?
Wow, Jaron, I love that logic, man. I finally got what you said. Definitely. Like, it leaves Santa Barbara. People in Santa Barbara see it disappearing over the curve, but people on the island still don't see the boat. So the boat is kind of like
it's in between. It's like in a crevice.
Twilight Zone. There.
Yeah,
then it appears, to an observer on the islands. But somebody from this point of view, looking down, they're like, hey, the boat's out there. And so there is a dead zone in between where nobody sees it.
Right. Absolutely. You just said it perfectly.
Wow, that's a powerful...
Well, and this is the hard part, is because, I live up here in the Monterey Bay, just, a few hours north of you. And, I've seen that observation myself. We sat at the, I believe it's Moss Landing area, and watched, maybe a little bit of Aptos, but watched boats go from Santa Cruz across to the Monterey Bay. And you can watch the boat, you can follow with your camera all the way along the horizon line. It just goes all the way across, and then you can watch the boat go back. But I've been in Santa Cruz, and I've been at Pacific Grove and watched boats leave you, and after a few minutes, sometimes it takes 15, 20 minutes, the boat disappears, going off into the distance. So if it went over the curve for me, but it's not appearing to the other person, and it's just ridiculous, because you're right. It's almost as if there's a crevice, and I can't really draw it on the screen, but, it's... The boat in the middle out there would be seen by neither person, but it can't be behind the curve for both. It's
exactly.
Just, that's why I love these observations, and I really do think the third point perspective, it proves it all, and that's why, surveyors always take the one-person point of view. They take their observations from the single point of view, the one-person perspective, so when they see things, getting smaller off in the distance, they call that curve. And it's been, they've convinced the world of that for hundreds of years. So, yeah, I love this picture right here, because it really shows what I'm talking about, that from this height, you would watch that boat travel simply straight right across, not traveling over any curve. And yeah, people at either location would lose the boat quite quickly.
Exactly, yeah.
So, yeah, anything else in this particular video? There's so much good stuff, and that's the video that's called, what is it called? Eyes? I forgot what it's called.
Yeah, Eyes of Glory.
Eyes of Glory. There you go.
It's a compilation of my first high-resolution images, 24 megapixel images that I took with my Alpha 6000 camera that I showed earlier with the zoom lens on there, and it was a clear day, and I was just blown away.
Is that near infrared, right? That's not.
This is near infrared. This is 830 nanometer.
Okay, 830.
Near infrared, and I mean, if you compare this to, actually, let's do that real quick.
Sure.
If we compare this to my first aerial, infrared video, where is it? Epic 500-mile visibility. You'll see how bad the. What happened?
Yeah, I don't know. It's taking a second. As it's been known to do.
Yeah, exit the screen, maybe that.
Yeah, maybe there you go.
Oh, here we go.
There you go. Skip that out. There you go.
Okay, yeah. So, I mean, look at the poor quality here, right?
Oh, what a difference.
Yeah. Isn't that crazy? But still, I mean, this video got me so excited. But yeah, the difference is just incredible.
And again, I don't know, we certainly weren't taught it, but I think people think that if the Earth was flat, you'd be able to see forever, which is just simply not true. That there's so much atmosphere in the way. And then
right.
Plus the limited angle, and then plus the fact that things get smaller with distance. So, it's just like the people who say, well, if the Earth's flat, why can't we see New York from Spain? Or, why can't we see it? Which is just ridiculous. You will never see anything across the Atlantic Ocean ever, because anything that exists is way too small. So you would never be able to see that far anyway. But you're seeing, hundreds of miles here, which is, simply incredible. And eventually everything is too small, and then you're looking through too much atmosphere, even though you're looking above it. Eventually, since you're looking down at the horizon and down at the Earth where the heaviest distortion is, you're going to run into that problem.
Right. The thing about observing from above is also, we should mention this, the higher you are, it's true that we can see farther, but also the difference between the flat Earth and the curved Earth increases drastically, and when we get up to an altitude where the horizon should be around 2 degrees down, that's the crossover point, because as I mentioned earlier, it seems like the horizon tops out at 2-degree depression angle. So at 35,000 feet, I think the horizon computes down at about 3.4 degrees. So now we're starting to more conclusively tell that it's flat, So, yeah, I've seen some people comment saying, yeah, dummies, the higher you are, the farther you see. But what they may not be grasping is that we're seeing farther than we should.
Right. And yeah, that's another thing that's been touted as proof of a sphere. It's like the higher you get, the further you can see. It's like, yeah, that would work on a flat plane as well. If a child is 3 foot tall, they can certainly not see as far on a flat plane as somebody who's 6 foot tall. And somebody who's on a 50-foot mountain can certainly see further than the child, and certainly further than the 6 foot tall adult. So people just seem to not realize that. And all these images that I see, used to be, in my opinion, like a sign of curvature or a sign of a curved Earth. And now when I look at it, they're simply not there anymore. It's not showing the signs of being a sphere. It's showing the signs of being as far as I can see. And then again, we only see in a circle.
Right.
So if you bring up the San Jacinto video one more time, because I know that's a big, that video that I did about your observation, I think has 100 and something thousand views. I haven't looked at it in a while, but it's been getting a lot of traction, a lot of, it's kind of gone viral, quote unquote, if you will. But one of the things that I thought was most amazing about San Jacinto is, and let me actually show people real quick. I'm just going to show them the Google Earth image because I think people might not really see what we're looking at here. You might not be able to see what I'm doing, JT, real quick.
Okay, that's fine.
Yeah, I'm just showing Google Earth, and then I'm showing them that where the mountain is that we're actually observing, which is way back here. And again, you have to remember this. If people can see these two lines, this line here is where the actual horizon should be. But we're able to see the shore, and we can see this breakwater here, and all these things are in your image, which should be behind this curve if this is where the horizon is. But also, if you see, I'm just dragging this little observation across here, and you can look down in the lower right-hand corner. I'm going to tell you about the elevation. So right in here, we're at 30 feet. This is 14 feet. As we get back here, we're at 50 feet. But look how far we have to go. This is 100 feet. We're still moving. So people need to recognize that all this stuff is in the way of that observation. 193 feet. We're actually nowhere near what we're going to get to. So we're at 168 feet. And look at what we're viewing. Keep going here. Keep going here. Keep going here. Now I'm at 155 feet. As we keep going, I'm at 380 feet. Now we're at 343. Now we're at 500. Going over a hill here at 600. Going over more hills at 600. Now we're up to 1,000 feet. Now we're going past, this is 1,000 feet. Let me get up a little higher here. Now we're at 1,300 feet. So people need to recognize that all this stuff would be in the way of that mountain on a flat Earth or a globe Earth. But I'm just saying, people for some reason, I think that you'd be able to see the bottom of Mount San Jacinto, and nobody's claiming that. Here we are, 800 feet. As we move further along, we're at 600 feet. Over here, we got 1,000 feet. So all this stuff is going to be blocked, especially, as I just said. So right here is 1,500 feet. If I move back here and we get even lower, you're going to be blocked. And then look at these mountains that block it. This one here, 1,800 feet. Going over this mountain, which is 2,000 feet, 2,200, 2,300 feet. And then you still haven't gotten to Mount San Jacinto yet, which is way back here. And in front of it, you've got 4,000 feet, 3,000 feet. So really, and then if you kind of watch this Google Earth image, you'll see that mountain fall behind the curve as I back up to here. But again, people might say, well, I can still see it. Well, yeah, I'm also at an eye altitude of 17,000 feet. So let's get down a little bit, and you'll see that as we get to, I hope I'm looking at the right observation spot. Oh, Point Dumais is over here. But anyway, as we get down here and look, I guess I drew the wrong line there. The line should be this way. But now we're down to an eye altitude of 150 feet, and you can see that falls behind the curve. See that? And you can see everything that would block it, which is all this land features here. So anyway, I just wanted to show people all that's in between. Let's redraw this line here because I didn't do a good job of it before. I had the wrong location there. But yeah, so the line is just right here. It's right next to this one anyway. But same thing, all these land features. And actually, as we get close to, what is this lake over here? What is that lake? I don't know what the name of this lake is over here. This Paris Reservoir. Yeah, it looks like it's surrounded by huge mountains, 2,000 feet here. And again, over here, 2,000 feet. So yeah, so people, I think, when they're looking at, go ahead and bring up again. Oh, you have it up, I think. Yeah, Mount San Jacinto observation point. Yeah, there we go. So people need to recognize what we're looking at across, and then all that land features, the buildings, that's all that stuff that kind of ramps up on the way to Mount San Jacinto.
Right.
So, oh yeah, and you have a little diagram there. Can you kind of explain a little bit the diagram in the lower right?
Yeah, in my previous video, I sensed that people didn't quite get what I was talking about, and I had labeled a tangent point, and that threw people off. But yeah, there's obstruction. So if we want to use a calculator, right, curvature calculator, well, that shows you how much is hidden if you draw a tangent to the mean sea level, which is this blue line. But then, because there's buildings in the front, like we obviously see in the picture, right, those buildings block some more of the mountain. So that's what I'm trying to show there. Now, to figure out how much of the mountain is hidden by the tangent to the mean sea level, yeah, we can use the theoretical calculators, given the radius of the Earth and all that.
Right,
and
yeah.
then we use perspective for the obstructions in the foreground.
Yeah, and of course the sites like Metabunk and those things, they all presuppose the globe, which we know the problem there. And then they use this 7.6 to get how much we're seeing extra, which is, again, terrestrial refraction, which is just a number. It's just a mathematical equation that's plugged in, and I've talked about mathematical equations and how they can be used to trick us because, again, if you're talking about observations only, it's one thing, but what do? They throw in mathematical equations to make the observations fit the sphere.
Right. I've seen some people use. There's another program, Peak Finder, and my opinion on these tools, the software tools, is they have to have refraction models in there to show, actuality.
To show what we see.
Yeah, because if it doesn't match reality, then it's really not useful, So it may be that some of these tools use refraction to, bring objects up and give a more accurate representation of what one should be seeing. But yeah, when you actually calculate it based on theoretical stuff, it's like, wow, it just doesn't fit the globe model,
No, and then I know I pointed out a video to you earlier. Now I don't remember the name of it, but
Indio 007, I think it was, something like that.
Yeah, actually, oops, yeah. Oh, yeah. Can you bring it up? Or
yeah, let me actually.
hold on, I can actually go and find it again because I know the name of it was the final words for the final word. San Jacinto. Just because I want to point out this video, it doesn't have very many views. Yeah, this one here. So I'll bring this up for people to see. There we go. Oops, that's your screen. Sorry. Let me bring up my screen. I was like, there we go. Oh, that's not what I was looking at. Yeah, so this video is called, let me transfer this over for everyone to see. There we go. Is called the Last Word on San Jacinto. It's by Indio 007. Again, it's only got a couple hundred views, 290 views. But this is a great video that goes through and kind of talks about this observation. But then when you get to about 7 minutes, he starts coming up with the conclusions. And he's got this all laid out like Globers want. They've got it on there. I think he's using GeoGebra here. Yeah, it's GeoGebra. To show, and he gets to the conclusion where, no, nothing matches what the globe should say. Number one, you've got a horizon line way too short. Like I think he shows it here. He's also showing you that we can see these features that are on the beach in this video. You can see here, these things are the shoreline. And this is the inlet here at Marina del Rey. Well, all these things should be well hidden because if you do the curve calculator, especially the Metabunk curve calculator, it tells you 15 miles, I believe, is where the horizon should be, and then there should be a bulge between you and this far distant mountain of like 2,000. I think it's like a half mile, 2,500 feet. So yeah, so definitely check out this video. I will put a link. Copying it now so I don't forget. I'll put a link to this video in the description because I think he does a great job. And you said you got to see this video?
Yeah, I did. Yeah. It's very interesting. I like how he kind of changed the color here and zoomed in. It looks a little bit more natural.
Yeah, he just does a good job of showing that it doesn't match, the globe. And I think that once you understand what the globe would mean and where this mountain would actually be, and that you would be seeing, the top of the mountain from behind the curve. I mean, it's baffling to me that people just want to keep arguing against the idea that the Earth could be level when observations are showing us exactly that.
Exactly. Yeah, it's kind of shocking. I mean, let's be honest. When we first hear about this stuff, man.
Oh yeah.
Yeah. Our brains hurt.
No, they do, and mine still does every day because I'm still looking at things, and I don't know about other people, but for me, the more I dig in, the more evidence I'm seeing that something is awry here, something big. The more you go back and look at these tests and experiments that I did a recent video on Einstein and how he made the Earth move, and when you really dig down,
I saw that was great.
Oh, thank you. Yeah. When you dig down and find out that there's no experiments or tests that show the Earth move, but yet they're teaching it as scientific, there's a problem there. I mean, that alone should get people to say, okay, we got a problem. We now have pseudoscience being taught as science. But it goes far beyond that. It goes to the point where you will get demonized. I'm sure you've gotten comments that you'd rather not speak of or wish you would have never seen.
Exactly.
Right. It's just people that are losing their mind over it, and that's fine. It's not for everybody. That's the thing. Flat Earth is not for everybody because it's way down the list of conspiracies that you need to realize first that, yes, groups of people can get together and lie to you, especially if it benefits them in the end. And so, yeah, it certainly looks like these observations are telling us that the Earth is not at least what we were taught. Now, I've heard a lot of people say, well, couldn't the Earth be a lot bigger? Sure. Yeah, that could be a part of the lie. Maybe we were living on a planet the size of Jupiter. Who knows? But as far as the numbers that we've been given and the numbers that they've told us, this 25,000 mile sphere, and I still think that, originally they may have said 25,000 miles and then they realized that people were seeing too far. And so that's when they input this 76R to basically make up for the fact that people were seeing too far. Well, the problem is now we've got infrared photography, and now we've got long-distance zoom cameras like the P900 or even the better zoom at the P1000. And so now they're kind of at a point where they can't go now and say, oh, it's actually 86R, or they've kind of already cemented these distances in and these circumferences of the Earth. And so now they've got a problem that we are clearly seeing too far.
Right. Yeah, I'm an RF engineer, and a while back I was looking at data. I cannot go into details, but I was puzzled. Long range detections, and a fellow engineer sent me this paper from a expert at Sandia Labs, and I thought it was very interesting. The first line in his abstract said, "The Earth is not flat, and radar does not travel in a straight line," something like that. And that told me right away that he knows, something. So I looked at papers, and ever since World War II, right, now we had something different than just optical. And there's these long-range detections that are puzzling. So looking at one of those papers, I saw these models for refraction that you mentioned, and that's what they use, as a ballpark figure. They use this model that gives you 4/3 R, I think it is. And the Navy studied it quite a bit. There's quite a few experiments out there. One of these days I'm going to do a paper on that. But you were asking, like, what are my next projects? One of the projects I have cooking is I want to pick up telemetry from aircraft. They transmit the ADS-B signal, and I'm building an array, a phased array, so I could get really narrow beams and increase the gain. And I believe, I've done calculations, if I go on top of a mountain, I'm not kidding you, I think I can see 2,000 or pick up signals 2,500 miles away if the Earth is flat. So I'm taking this to the next level. I want to go really long distance, but at the same time, I want to build an interferometer. So now not only do I detect a signal, but I could tell accurately the azimuth from which it came. So see, now I can have a tool to get data points on a map. And then I'm going to put all this in MATLAB and see, hey, which map is more accurate? So, when we take things to these distances, man, that's going to be the ultimate,
Yeah, no, I totally agree. Like I said, I just sent off my P1000 today. Everything I've heard and every place we've asked has said they couldn't do it, but I did find somebody who was willing to take a look and try and do it, and said, I won't ruin your camera. So I said, okay, don't do that. But my hope is that I'll have my P1000 back, in a week or so, and that it will be converted to infrared. That's my hope. If not, well then, I'll have to look into possibly a P900 and doing infrared on that. And then I want to go back to the Monterey Bay and do some more observations there. I love the mirror tests because really for me there's people can talk about looming, they can talk about refraction all they want, but I understand how a mirror reflection works, or a heliograph is what it was called in the late 1800s, early 1900s, which is basically a signaling device. And for somebody to see a reflection off of a mirror, you must have line of sight. There cannot be anything. The second anything obstructs that mirror,
Right.
there's no more. You cannot see a reflection from the sun anymore. So I want to go further with the distances across the Monterey Bay. Last time they did 13 and a half miles. I think we can stretch that out to 20 next time, and pick up a mirror reflection of the sun from 20 miles away. The problem with that is, well, at 13 miles alone, there's supposed to be a 40-foot hump of water, a 40-foot bump, a hump, if you will, between you and that mirror, which means there's no possible way you would be able to see that reflection. It's blocked by a 40-foot tall obstruction, and yet we were able to see it. So if we stretch that out to 20 miles, I'm not sure. I can look real quick and see what is the amount of hump on that. Let me see if I go to Metabunk curve calculator. So that's what I want to do next. Let's see, Metabunk curve calculator. I'm just going to type in real quick here, distance in miles 20, and a viewer height. We'll just leave it at 6 feet. So the bulge there is supposed to be 66.6, imagine that, 67 feet. So again, if we have somebody sitting at the shoreline and somebody with a camera 20 miles away, and we're able to see a reflection of the sun, you have to have line of sight to the mirror. There's no rays coming off the mirror that are going up over the hump, and that's what you're seeing. You need to see the reflection. That's how heliographs work. So that's my next observation. And then tell everybody just one more time, because I am going to go, I'll probably have to order them online. I didn't see any locally, to get the 3D glasses. But exactly what you think the 3D shows that the 2D doesn't. One more time.
Yeah, so in 3D now, we can tell the angle of the surface and if it's got any curvature. And in that video that I'm about to post here shortly, Louisiana in 3D, I tell you, look at that thing and it's like a flat plane that goes out. And I've identified some of the lakes in the distance, close to, 200 miles. Well, the calculator tells us that's roughly close to where the curvature or the horizon should be, right? But when you look at it, it's just a flat, plane, and then all of a sudden it just gets cut off, perhaps due to, attenuation, haze, whatever. But yeah, in 3D, you get the perspective that it's really flat. I mean, if you had any doubts that it's flat, now those doubts are gone. I mean, it is flat, Jared.
This is what's sad, is that I'm the most excited about going and getting 3D glasses now. I'm like, man, is there anywhere open? It's only 9 o'clock, and I go because I gotta see these three videos.
I don't think Best Buy has it, because I went over there.
No, I don't think so either.
But who knows? Maybe your Best Buy does.
No, I looked online right before we went online. Right when we went on the air, and then I also checked Walmart. But yeah, local stores didn't show any 3D glasses. But I have to look at those 3 videos because the way you're talking about it, it already looks flat to me. And you're saying that when you put these on, that it looks even flatter. I'm like, I got to see this because I can't picture it getting much flatter.
Right. Right.
So, and then just real quick, I didn't show everybody, so I'm showing now the Metabunk curve calculator, and you can see down here what I'm talking about. Imagine we've got somebody over here with a mirror, and you can picture the sun being up here. It's reflecting off this mirror. In order for this person to pick up the reflection of the mirror, there cannot be a bulge here. And it's already been done at 13 miles, where at 13 miles, the bulge height, if you're talking about versus this tangent line here, or this line, actually it's called a chord. If you're talking about this chord, the distance between the chord line and the hump, the bulge distance, I think there's another name for it too, but it's supposed to be 40 feet high at 13 miles, which means how were we able to see, or how were they able? And if you want to check out that video, you can check my channel or go to Flat Reality Earth Explorers. But check that out, and you'll see that there's a mirror on the water. So, the mirror is at water level here. You've got a camera 3 feet high here, which is much smaller than this. So you should be blocked by the horizon. How are we able to see a reflection of the sun? And again, any obstruction of this mirror, doesn't matter if the obstruction's here, wherever the obstruction is along this line, will block the sun reflection off the mirror. It's not as if the mirror is reflecting light and somehow you're seeing it over here. That's not how mirror reflections work. So that's I just wanted to show this real quick. But yeah, everybody, please go to the description of this video and subscribe to JTolan Media 1's channel. Get yourself some 3D glasses. And JT, you said that those could be cheap ones, right?
Yeah. I think they're like a few bucks,
Yeah, I think I looked on Amazon after, and I saw some for you can get 5 pairs for $10 or something like that. So even those kind of cheap ones would work. You don't need to go get the $100 ones, right?
Right.
Good. Okay. Good.
Yeah, I'm hoping it's a standard, right? The red and the cyan glasses. I hope that's a standard because I've tuned the colors based on the glasses I have. So, let's hope that they're all the same,
Yeah, I'll hope so. I'll let you know when I get them. I'll probably order them, and hopefully they'll come in a few days. And then, I would love to observe your stuff. Anything else that you want to show people or tell them that's coming up on your channel, or is that about it?
Yeah, that's about it. Yeah, I'm working on this 3D stuff, and like I mentioned, I'm doing some RF stuff. And anyway, yeah, I wanted to thank you, Jaron. I appreciate you, giving my channel a boost.
Yeah, no problem. No, I'm all about showing people where they can find good people making good observations. I've done videos before with Wide Awake Dave, who has a great channel. If you haven't seen that channel, subscribe to that one too. He's got some great observations from Florida of boats floating in the air as they go out past the curvature, which he'll talk to you all about that. But yeah, I had Ranty on. Anybody who's got a channel where they're making great observations, I want to bring on and let them tell people about it. So yeah, definitely check out his channel. Some of the videos are unbelievable, simply amazing, or simply incredible, as JTolan would say, much better than I can. And I love that little song that always plays in your videos too. I don't know where you got that from, but it's very cool. Real quick on the super chats, I see Joshua Doyle said we need to get some super chats going. Thank you, Josh. Another person, Josh Doyle again, said non sequitur show sucks donkey dong. Yes, I would agree with that. That's good, Josh. Thanks. And somebody else, Flat Earth Perth, said GoFundMe 30 Zoom drone. So it's number 30 ZOOMDRONE. Thanks, everyone. Stay flat. So definitely check that out. The GoFundMe for 30 Zoom drone. I will check that out myself. Thank you, Flat Earth Purse. So thank you, everybody, for those super chats. I really appreciate it. And thank you, JTolan, for coming on and telling us about your channel. And hopefully people watch some more and we can see some more awesome observations. And hopefully I get my camera done. That's the hope, that I can have a P1000. Maybe I'll be the first one with a P1000 that's converted. That's if this guy Isaac can do it as he thinks he might be able to. So we'll wait and see. So any final words for everybody before we go?
No. Yeah, there's a mystery out there, and I'm curious like everybody else. So yeah, stay tuned for more videos, everyone. And thanks, Jaron. I sure appreciate it.
Hey, no problem. Thank you, everybody, for watching. If you want to support this channel, you can do so in a few ways. You can send super chats. I just got another one from 550 What. Thank you so much for that. That is awesome. You can go to paypal.me/Jaron. You can go to patreon.com/jeranism. That's where you can become a patron. And if you want to just simply put in j.mp/JaronAMZ before you shop at Amazon, when you do that, I get a small percentage, which really adds up when a lot of people use that link. So thank you, everybody who is using that link. I'm guessing some people must have it saved in their bookmarks or something, because it's been a really great feature to have people using that link to buy stuff at Amazon. So if you shop at Amazon and you want to spend the same amount that you normally do, but you want to have Amazon have to kick me 2 or 3% of your purchases, j.mp/JaronAMZ. And that's it. Thank you so much for joining us. That was JT from JTolan Media and myself, Jaron from Jeranism. And always remember to do your own research, because when you do, you'll never again believe what you've been taught. Till next time, guys, this has been Jeranism. Peace.